Nuclear chemistry. With Bendix. The most important thing about nuclear chemistry is understanding the isotope. Isotopes are the same element with different numbers of neutrons. For example, carbon. There are 3 isotopes of carbon: carbon-12, carbon-13, and carbon-14. Carbon-12 is the most common and stable. Its nucleus has 6 protons and 6 neutrons. Carbon-13 is less common and less stable. It has 7 neutrons and 6 protons in its nucleus. Carbon-14 has 8 neutrons and 8 protons. Isotopes have a variety of properties and uses. Carbon-14 is slightly heavier than carbon-12 and will decay over time. Decay is measured in half-lives, or how long it takes for half of a sample to decay. Carbon-14 has a half-life of about 5,000 years. So if you had a 100-gram sample 20,000 years ago, how much would you have left? The answer is about 6.25 grams. You can figure this out by dividing the total time by one half-life. So 20,000 divided by 5,000, 4 half-lives. Then dividing the sample, 100 grams, by 2, 4 times. To simplify this, you can also divide the sample by 2 to the power of half-lives, or 100 divided by 2 to the 4th. Enough about carbon. There are more interesting elements to play with, like uranium. We will be using 3 isotopes of uranium: uranium-235, 238, and 239. Uranium is used for nuclear fission, the process of breaking up an atom into its smaller pieces. Uranium-235 is the most fissionable uranium. Uranium-238 and 239 can be fissioned, but it takes extra energy and doesn't chain reaction as well. When fission occurs when uranium-235 is hit by a neutron and splits into 2 small elements like calcium and iridium. It also releases 3 extra neutrons, which go split even more atoms. This generates a chain reaction and a lot of energy. Unfortunately, uranium-235 is the rarest of uranium isotopes, so we devised an insidious plot. We took uranium-238, the most common and stable of uranium isotopes, and shot an extra neutron into it, making uranium-239. Then we led decay. There are various types of radioactive decay: alpha decay, beta decay, and gamma decay. Alpha decay is 2 neutrons and 2 protons flying out of an unstable nucleus. It's basically a helium nuclei. Beta decay is an electron. Wait, since when have there been electrons in the nucleus? Well, there's a theory that neutrons are actually made up of a proton and an electron combined. So beta decay is simply those separating and the neutron becoming a proton, the electron is flying out of the nucleus. Gamma decay is by far the most dangerous. It is a release of a high energy wave. Alpha and beta particles will bounce off skin and tinfoil. However, gamma decay will go through several sheets of lead. Back to breeder reactions. The uranium-239 now undergoes beta decay, turning 1 neutron into a proton and releasing 1 electron. The uranium becomes neptunium. Beta decay happens again, turning the neptunium into plutonium. The plutonium is then fissionable. However, plutonium is the most dangerous element. It's radioactive for millions of years, and we have no way of disposing or dealing with it. Radioactive waste may lead to our doom in the future. Well, that's all. This was Bendix describing the wonders of nuclear chemistry. Boom!